Welcome learners. In this video, we'll talk about data patterns using space-time pattern mining. What is space-time pattern mining? It's simply a technique in which we visualize our data, we can say in 3D form. Space-time pattern mining tools we use for it to analyze, to incorporate the spatial and temporal aspects of our data, to help understand its spatio-temporal trends. The spatio-temporal mean the data which is associated with spatial means a location, and that data is studied with respect to time, that is temporal. First step, we can say initial step, space-time pattern mining is space-time cube, generation of space-time cube. Space-time cube aggregates our data into multi-dimensional cube data structure that is called as net CDF. The cube, this generated cube aggregates our data into space-time bins with respect to x and y dimensions, representing space and the time dimension. We use mainly three types of tools. Create space-time cube by aggregating points. We use it when we have to analyze incidents that occur in different locations over a period of time. We can say crime incidents in a state. Same way, create space-time cube from defined locations. We can use this tool to analyze fixed location with attributes that change over time, like county tax rates. How many tax rates are going to change from time to time. And then third one is create space-time cube from multidimensional raster layer. We use analyze to analyze multidimensional data that change over time. Okay, we can say rate of precipitation. We can analyze it on ArcGIS Pro. Let's come to move towards ArcGIS Pro. This is the data of US counties, which shows snap rate from 20. We can say it is 2019's data. So we have to go to analysis and then on click tools. After clicking on to, we have to search here times create space time cube, this one. So we have to first analyze by defined locations. This is the input features are our US counties. For output we can name and location ID according to our data is county ID, and related table is snap county rates, and relative ID is county ID. We can check temporal aggregation, but in case if we have a data of we can say monthly and we want to analyze it yearly, then but in this case we have a data of yearly and we are using, so we don't need to check this box. So for time field, there's simply time of years, and time interval we are going to analyze uh, only 1 years. So here we will use years and time alignment end of time. Okay, and for variables we are going to use snap rate, and for this one space time neighbors. So we have completed our inputs. Click on run and it will take some time. Yes, the process has been completed and there is option of warning, but simply we can see here your spatial reference system is not compatible. It don't affect our results. So we have completed our first task. The results are shown here and messages we can see. These are related to some reference issues, but don't need to cooperate with them in this stage. So this has been done, and if we want to analyze our result to visualize on the map, we have to move backward. And now we are going to search here, type time cube 2D as this is in 2D. We click and we have to input our the space where we have been outputted our result in the last task. So the output is here and we click to add it here, and q variable is going to this one and display is trends, and we can check it, and here we can type for it output, that is this one. And when we click on run, the process has been started and the data will be visualized in 2D form. Yes, there has been. This is the output. Visualize spacetime cube in 2D completed. So check our result. We can check the trend in our data. The green are showing low trends and purple are showing high trends, that they have participated in some activity. So we can zoom in and watch the results. For zoom in, we are going and we can check here. We have to click this county. As we click here, the pop-up window will show some results. Yes, this one. Okay, we can't see here, but when we click on this button, there is a chart. It shows we can increase the size. This is the trend from 2000, how many values have been. This is so we have displays our data in 2D dimensional. Here in on x-axis, uh, years are given and the snake bread over time neighborhood is given here. How many increasing or decreasing with increasing time period. So this is the method we can visualize our data as well in 2D form. Now we will move towards how we can show our data, this space-time data into 3D. So this is all over. We can print as well this information. Same way we can use for this one, which is showing a higher value. So this is the trend which is showing that the values for this increasing continuously. This is the trend in data over time, and that is given all summary of the uh, data recording the z value, trends, and the neighborhood, the shape length, shape area, etc.